All right, so in 10.5, we focused a lot on angles. We figured out how to find the measure of the angles that are inscribed, the ones that are on the circle, the ones that are outside the circle, and then those floating ones. 10.6, we switched the focus back to lengths of segments. Okay, so you're either going to learn how to find the length of a tangent segment, a secant segment, or chords. All of them are segments. Otherwise, we can't find the lengths of them. So the segment of chords, because you're going to see this terminology, is if two chords are intersected in the interior of a circle, each chord is divided into two segments called the segments of the chord. God bless you. So this chord, when it intersects this chord, is divided into two parts, and we call each of those parts a segment. So this is one segment, this is the other. This is one segment, this is the other. Okay, Theorem 10.14, which is just the 14th theorem in chapter 10, says if two chords intersect in the interior of the circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. So when our two chords intersect inside the circle, in this case, M is where they meet. I can say that AM, which is this part, times MC equals DM times MB. So you have to keep the ones along the same chord together. Okay, you can't crisscross those. So it doesn't mean they're equal. Like you can clearly look at these, that they don't look like they're equal, but their products are equal to each other. Okay, so now we've got tangent and secant segments. A secant segment is a segment that contains the chord of a circle, has exactly one endpoint outside the circle, and the part of the secant segment that is outside the circle is called the external segment. So the secant has to pass through the circle. It's the difference between the secant and the tangent. The tangent's going to hit it at just one point but not pass through it. But a secant segment is no longer a line. It has endpoints. And the part of it that's outside the circle we call the external segment. To quickly go back to this real fast, the tangent segment would be the one, obviously, that hits that circle at one point. Okay, and it's a tangent, typically is a line, but this is a tangent segment, which means it also has an endpoint. So secant crosses through the circle. All right, Theorem 10.15 is segments of a secant theorem, which says if two secant segments share the same endpoint outside a circle, then the product of the length of one secant segment and its external segment equals the product length of the other secant segment and its external segment. So for secants, because it's going to be different for tangents, for secants, I do whole times external equals whole times external. So the whole segment, like ln, times the external part, which here is mn, would equal the whole other secant, which is pn, times the external part of that secant, which is on. 10.16, Theorem 10.16 is segments of a secant and tangent theorem. So this is a secant and a tangent. If a secant segment and a tangent segment share an endpoint outside the circle, the product of the lengths of the secant segment and its external segment, which is the same thing as the last one, but this time it equals the square of the tangent. So in the last one we had two secants. This time we have a tangent and a secant. And the formula for this one is that the tangent squared equals the whole secant times the external part. So in the diagram that's there, ML is the tangent. ML squared would equal the whole secant segment, which is JL, times the external part, which is KL. Those are the three theorems you got to know. The two chords, where the product of one is equal to the product of the other. Two secants, whole times external equals whole times external. And a secant and a tangent, which is tangent squared equals whole times external. Now I got to figure out which one you're looking at, okay? So example 1 says find the value of x. What kind of segments are those? Those are two chords, right? So I use the products of the chords. I would do x times 3 equals 2 times 12. 3x would equal 24, and x would equal 8. So make sure you group them along the chord. I can't group x with 2 or x with 12. X has to go with 3. Questions on that one? All right, B. What two segments are these? A tangent and a secant. So the tangent squared equals the whole secant times the external part. So the tangent is x squared equals the whole secant. So what's the whole secant? 24 times the external part, which is 6. X squared is 144. And x would equal plus or minus the square root of 144, which is what? 12. And typically it's plus and minus 12, but what do we know about the length of a segment? Can it be negative? No, so we just keep the positive 12. 100. Anytime you've got a squared variable equals a number and you go to square root the other side, the algebra rules say that you have to do plus and minus because technically, let's say it's 25, right? X squared equals 25. 5 itself squared is 25, but so is negative 5, right? So the rule is if it's an even power and you go to take the root on the other side, you're supposed to do plus and minus. The difference is here, we're saying that this represents the length of a segment, and a length can't be negative. So you just keep the positive 12. Good so far? Questions? Okay, now look at C. What kind of segments are these? Secant segments, so it's whole times external equals whole times external. What's the whole top? 12. What's the external part? What's the whole bottom? X plus 6. What's the external part? 6. So this is 48. This is going to get distributed into both of these. 6x plus 36. And then I would subtract the 36. 12 equals 6x, and x equals 2. Okay, so D is what? Tangent and a secant, right? So tangent squared equals whole times external. So tangent is 10. The whole segment here is what? X plus 2x, which is 3x. 3x times the external part, which is x. 100 equals 3x squared. Divide by 3, where it gets a little uglier. X squared equals 100 over 3. And then I would square root both sides. I don't need to keep the negative because I know this has got to be at segment length. But I get the square root of 100 over the square root of 3. What's the square root of 100? 10. Can I square root 3? What do I do if there's a square root in the denominator? Multiply both. Good. You got to rationalize this. You can't leave it that way. So all those rules from algebra are going to come back into play. 3x, so I multiplied these two together. 3x times x would be 3x squared. All right, let's try this as a team. So first let's do the setup. This is what two types of two secants, so it's whole times external equals whole times external. So whole on the top, we already did this one, is 12, external part is 4. Whole on the bottom, x plus 2, times the external part, which is x. Ladies. Okay, now this has to get distributed, right? 48 would equal x times x, which is x squared, plus 2x. As soon as you get to this point, as soon as you see that there is something that is squared and there is something that is not squared. Up to this point, if we had a squared, we only had 1. That's the difference, okay? As soon as you get to the point in which you see something squared and something not squared, a little light bulb's got to go off in your head and say, oh my gosh, I have to factor this. And then you have to try not to freak out. Because all you have to do is get everything to the same side. So I like to keep my x squareds positive. It simplifies it. So I move whatever's on the other side on the side with the x squared. That way I don't have a negative x squared. Which means I'm going to take this 48 and I'm going to move it over to the right. And I get 0 equals x squared plus 2x minus 48. Now I want to factor it. So I set up 2 parentheses. The first space in each parentheses is the factors of the first term. So what 2 things multiply together to give you x squared? X and x. The last number is the 2 factors that multiply together to give you this negative 48 in this case, that add up to positive 2. So if you have to go through the factors of 48, go through them. It's 1 and 48. Obviously, those are not 2 apart, right? 2 and 24. 3 and 16. 4 and 12. Can't go 5. 6 and 8. 6 and 8 are the 2 that are 2 apart. So the bigger one takes,
what do you mean by 2 apart?
The difference is 2, right? Because I need them to be, if it's a negative here, then I need them to be different signs, right? Think about the product. So 2 numbers multiplied together, if they're both positive, gives you what? If they're both negative, it gives you? So if that's negative, I need 1 positive, 1 negative. You with me? And I need the bigger one to match the sign in the middle. So it would be x plus 8 and x minus 6. Okay, you can check this by multiplying the outer 2 and the inner 2. So this is negative 6x plus 8x, which is positive 2x. You want that to be the middle term. So what we did works, because that, if you multiply back out, it works. So now, the reason why we can solve this is because if either one of those parentheses is 0, what happens to the other one? It's 0. If I have the left parentheses be 0, that whole line is 0. You with me? If I have the right parentheses be 0, the whole line is 0. Do you say you're confused?
No, I said there's 2 answers.
There are 2 answers. So I set each of these equal to 0, and I solve. So this would be x equals negative 8, and x equals positive 6. So if I'm just factoring and solving, that's my answer, negative 8 and positive 6. But I'm using those to represent the length of a segment. So what happens? You keep just the positive one, right? I can't have the length of a segment be a negative 8. So I rule out the negative 8, and I keep the 6.
That's the answer?
Can't be negative. A side length can't be negative. You can't measure something and get a negative.
How did it change? Because it says like minus 6, but now it's positive.
Because I would have solved that. I would have said x minus 6 equals 0, and then had to add the 6 to the other side to solve for x.
So that's the answer?
So the answer is just 6. Yep.
Can you explain more about what you did in the x?
The factoring part. So let's start from scratch. Try it. Solve it. Those of you that are ready, try it and solve it. Let's pretend we already did the geometric part of it, right? We took the left side and squared it. And we're here. See how? All right, so what's the first step? Bring the 12 over. I'm going to work it out. Okay,
Should be an algebra.
now factors of x squared are x and x. And now I'm looking for the factors. So two numbers that multiply together to give me negative 12 but add up to negative 4. Which would be what? Negative 6, positive 2. They have to be different signs because the last one's negative. And the bigger of the two should be negative, right? Negative 6 and a positive 2 gives me negative 4. So that's the factored form of it, but now I have to solve these. So if x minus 6 equals 0, then x would equal 6. And if x plus 2 equals 0, then x would equal negative 2.
So can you explain the negative part again? Like which one should
Yeah,
be?
so if the last term is negative,
So negative 12.
if the last term is, so there's two types, right? There's either a last term being negative or a last term being positive.
So since it was negative 12.
In this case, it was negative. If it's a negative, then there's one of each sign, right? Because a positive times a positive is a positive, and a negative times a negative is a positive. So these would be the same sign. Okay?
And the bigger number.
And then the bigger, if they're different, the bigger number matches the middle. So if the middle is negative, then the bigger number is negative. If the middle is positive, then the bigger number is
So
positive.
if it was positive 4, then the answer would have been negative 2.
Correct. Well, when you factored it, you mean?
Yeah.
So if this was x squared plus 4x minus 12,
It would have been negative.
I would have gotten plus 6 and minus 2. And then when I solved it, it would be positive 2. But yeah. Okay, wait, sign from middle. I think I have a factoring video from forever ago that goes through all the different types of factoring. I'll try to find it. Same sign. The sign would match the middle. So again, I would recommend that you always keep the x squared positive. I would move the ones from the right-hand side to the left this time. So as I move them left across the equal sign, they're changing signs. So I would get x squared minus 3x minus 10 equals 0. And then factors of x squared are x and x. Factors of 10, that's negative 10, sorry. That sum to negative 3 would be what? Negative 5, positive 2. Set each of these equal to 0. Add the 5, subtract the 2. And because we're talking about lengths, I would keep the 5. If you were just factoring this question, if it was just a factoring and solve, then my answer is both of those, 5 and negative 2. The only reason we rule out the negative is because we're talking about geometric side lengths. Make sense? Yes? Okay, what if they're the same sign? Wait. What? I mean, you could. X squared plus 4x plus 3. When I factor this, now they're both the same sign. X would be a positive 3 and a positive 1. I'd end up with negative 3 and negative 1. So if this was in the section I'm in which I'm solving for a length, there would be no solution. If this was just in a factoring question, then my answer would be negative 3 and negative 1. Questions? Okay, so if there's something in front of the x squared, I actually should look at your homework and see if you even get this before we go into it, but it's a good review either way. Okay, so for this one, I would still bring everything to the left side. I'm always going to keep that x squared term positive. Now when I factor, the factors of the first term are the factors of the first term, which is not just x squared anymore. What two things multiply together to give you 2x squared? 1 and 2, but they both have an x, right? So it could be x squared and it could be 2x. Those are the factors of 2x squared. Good so far. Now I'm looking for the factors of the last term that when I multiply the outer and the inner of these two, I get the middle term. So factors of positive 3 would be what? 3 and 1 or 1 and 3. So if I did 1 and 3 like this, I multiply the outer and the inner, I get 3x plus 2x, which is 5x. And that's the combination that works, so I know I did it correctly. If you had done the other first, oh, this shouldn't be x squared, this should just be x. If I had done plus 3
We can have to do that.
and plus 1, I'll look at your homework, but eventually, yeah. This is x
No, like this here.
plus 6x, which is 7x, and that does not match the middle. So this is trial and error, and I would know that this is the answer as soon as I get the combination that works.